All right, so we don't have time to go back through blood typing since we did it the other day, but with each one of the blood types, remember, there is either a positive or negative that goes with it. So like O positive, O negative, y'all know the whole 9 yards. Positive, if you've got a blood type and you're positive, that means what?
You have the RH.
You've got the RH antigen. So you've got one of those protein, whatever's on the outside of your cell. Glycoprotein, whatever it may be. You got that molecule that they've identified in rhesus monkeys as positive if it's there, negative if you don't. I want to say roughly 85% of people are positive. All the other blood types, A, B, AB, O, all of those vary with like origin, location of origin. Like if you're of African descent or European or Asian, they all are a little bit different. As I guess you would expect them to be, depending on how they're passed down. It doesn't vary too widely, but there is a little bit of discrepancy between the different blood types. So anyway, with the RH factor, if you are a woman and you get pregnant and you are a negative, so like O negative, B negative, whatever. Actually, we can close that door right there. Then if you have a child, your baby's daddy is positive. Then your body starts to recognize that RH antigen, and it's like, hey, this is something foreign, and starts to develop some kind of resistance to it, and then usually first baby's not a big deal. Second baby comes around, if that second baby is positive, if you're negative and the dad's positive, then it'll be 50-50. But if the second, third, whatever, it winds up being positive, then your body could mount some type of immune response to that baby and actually kill it. So, by identifying that antigen as something foreign and harmful, and so anyway, women take this thing called RhoGAM, which is a like immune suppressive shot for that RH factor. Basically, that's where the RH comes in RhoGAM. So anyway, that's what you have to watch out for. I'm pretty sure that's some type of test question. I'd be familiar with that. And y'all have heard, on the side note here, COVID, there's been some studies come out that talk about different blood types and how they're affected by COVID. O is supposed to be the best blood type for COVID. Although in terms of just contracting COVID, it seems as though it was a very small percentage difference from the other blood types. The big difference seemed like to me in the studies I read was if you get COVID, how the people that got severely ill had the other blood types. O was the least likely one to get severely ill. I think maybe like, it was like 50% less than the other blood types. And I don't know, I don't think they had figured out like why that might be. What about your blood typing might affect your ability, to fight off COVID. Maybe antibodies present within the body already, but it didn't seem to make a lot of sense, but there was some kind of correlation there. Correlation does not always equal causation. Just because there's some correlation doesn't mean that that's what causes it to be less likely, but they're still trying to figure that out. All right, abnormal immune system function. This would include most of you people. I've seen your medical pluses on the now. I don't know if y'all know this, but anything that you've got medical history, they put on there that we have to be aware of as teachers, in case you get a seizure and pass out in class, or if you've got an allergy to bees and I take you outside and you get stung, or if you've got a EpiPen and we need to watch out in case something happens.
So if someone has had a seizure in your class, you check on them?
You're supposed to check all that stuff at the beginning of the year and be on the lookout. There's a lot of different, we always think of seizures like people shaking and flopping around. And, there's a lot of seizures where it just looks like somebody's completely zoned out. Some days it looks like all y'all may be having one of those. So anyway, it's just something you need to know those people and make sure that you're aware of that if there's something different going on. So anyway, autoimmune disorders. Well, all of these fall under abnormal immune function. The first one here, let's talk about allergies. On page 965 in your book, this kind of goes into the allergy response here. Allergies are basically, your book calls it hypersensitive responses. It's things that aren't really bad for you, but that are foreign, and your body somehow interprets that it's bad for you, so it has a major response to it. Allergy, a false alarm. Mast cells are the problem by overproducing histamines, and most people that have allergies take antihistamines. Okay, so it may be something as like pollen, it may be an allergic reaction to peanuts or milk or shellfish or
What makes like some allergies worse than others? Like why?
It's all about how your body reacts to it. So if somebody's allergic to peanuts and they that's also at the top of 965. Peanuts, shellfish, some other things like that cause you to make it where your body it isn't able to breathe. We call that what? Anaphylaxis. So anaphylactic shock is basically a life-threatening reaction where cells in your air passages are constricting. And they constrict so much that it makes it very difficult to breathe, and you can die from anaphylactic shock. Someone who has like major peanut allergies, even like dust could cause an anaphylactic reaction where your body's like, those peanuts, they're so bad. I mean, for your body's cells though, it's really, there's something foreign and it's trying to do everything it can to keep them out. But in doing so, it winds up killing you. So that's a big problem.
What about those people that like don't have allergies they're born with, but they develop them like later?
I don't know that you're born with any, to be honest with you. It's just how your body reacts to them. There's like my wife had a cat for 10 years and then she developed allergies to a cat, which is kind of weird. Some people have allergies, like my son had allergic reaction to penicillin, but I read a story last year that said, and my brother's allergic to penicillin, which is like one of the most common classes of antibiotics.
I have a cousin that's allergic to penicillin.
And they said that 90 to 95% of people who were allergic to penicillin early on in life, if they got tested like 5 years later, they're probably not allergic anymore. So, but just most physicians and stuff don't go back and check because they've already had a reaction once. They just use a different class of antibiotics. So sometimes you develop them, sometimes you get over them. Places like, you remember Plumpy Nut from the, we'll watch that in here if we have enough time. This is video about kids in Africa feeding them this like peanut butter paste for nutrition. And the lady in the video talked about like, poor kids in poor countries don't have allergies. It's almost non-existent. And if y'all want to write in, the idea behind this is called Hygiene Hypothesis. I think it's the most logical explanation. It's not really been proven, but it makes the most sense, I think. Hygiene Hypothesis says that the more you're exposed to stuff like outside or different animals, the less likely your body is going to be oversensitive to different foreign substances that aren't a big deal. So, like if you grow up playing out in the yard or playing in the dirt, like some poor kid in a hut somewhere, and you've got animals running around, you're probably never going to have any allergies because your body's used to that stuff, different dust and particles and things. But if you've grown up like many good Americans inside, in air conditioning, in an air-controlled environment where everything's filtered out, and then the first time you really go outside and spend much time outside, you're 5 years old and you're at your neighbor's house out in the woods, and you get all these new foreign substances in your body, then your body starts freaking out. It's like, what is all this stuff? And you start having these allergic reactions. I think I read somewhere that if you have like 2 different types of animals in your house, you're like 50% less likely to have allergies to animals, something like that. So the more stuff you're around, the younger you're around it, the less likely you are to have allergies. Like when I was growing up, I grew up out in the country. I don't remember any kids at school ever having allergies. And now it seems like everybody does. And a lot of them are significant. I don't know if y'all know anything about peanut allergies. For a while, the American Pediatric Society or Association or whatever they're called, I think the recommendation was either a year or 2 years before you expose babies to peanuts. That's how it was when our kids were young. I can't remember how much it was. And then now they've changed that to where they say you should start, I want to say, check this out before y'all start exposing your kids. I want to say it's 6 months now where they recommend you start exposing them to like a little bit of peanut butter. Something with like peanut butter crackers or something like that. Because the idea would be the earlier they're exposed to it and the more they're exposed to it, the less likely they're going to develop something like if they wait a long time and then whatever it is about peanuts that makes people have such a bad reaction. Yeah.
What about like acid reflux and things like that? Like I can't really eat anything that's like dairy or really spicy or anything like that because it messes up my system like really bad.
I don't know if I would say that's an allergic reaction as much as your body's reacting to a certain. It's not like an immune reaction. This is a specific like immune response. I don't know that would fall like that would fall. That may be more having to do with like how acid or basic those are and how your body produces, chemicals to offset them. So I don't know that qualifies as a immune response. But that does change over. My mother is convinced that after she had me, like 30 years old, she developed acid reflux and has it ever since, and so she blames me for that. So, I mean, bodies do change over time, but that wouldn't be, I don't think, anything to do with allergies. All right, and then there's another group of disorders here in the immune system called autoimmune disorders. Auto means? Self. So these are self-immune disorders caused by faulty genes, faulty DNA. Read those first couple for us, Katie.
Lupus the wolf, characterized by a butterfly rash on the nose and kidney dysfunction, mostly women affected. Rheumatoid arthritis, white blood cells attack and break down the connective tissues, mostly cartilage affected.
All right. Lupus, y'all may know somebody with that. I actually know a couple people with lupus. It's one of these weird autoimmune diseases where it affects different stuff in your body. Requires a ton of tests to really kind of figure out what it is. It's not anything that's just simple to like diagnose. And like I say, for some reason, it seems like mostly women have it. The two people I know have it are women. Rheumatoid arthritis is where your body is attaching its connective tissue like in your joints. And I don't know if you've ever seen anyone with hands like on 965. Used to have this guy I used to greet with at church. His hands looked exactly like that. I mean, they were very gnarly. He went to shake your hand. I mean, he couldn't hardly shake your hand. My aunt has hands that her knuckles are really swollen and the joints get pushed out of whack. And it can happen. I've had a student before who had that. So it can happen early on or it can happen later on where your body attacks that connective tissue. Number 3, Walker.
Insulin-dependent diabetes or type 1 juvenile diabetes. WDCs attack the pancreas cells that make insulin.
Okay, so there's 2 types of diabetes we normally talk about. Type 2 is usually referenced as what kind of diabetes? How do we characterize it?
Like, what do you mean?
What do we associate with type 2 diabetes?
Like that?
Obesity, usually. And so basically, I don't know if you ever watched that show Biggest Loser. A lot of times people would come on Biggest Loser and they would have type 2 diabetes, very large, very like high overweight group. And then if they lost a lot of weight, like by the end of that, they wouldn't have to take their type 2 medication anymore because basically they weren't type 2 diabetics anymore because their body could then process the food that they were bringing in and taking. It's basically to the point where you're bringing in so much food and sugar and stuff that you're not able to keep up with insulin production is where type 2 comes in. And so we're seeing that in younger and younger people as obesity rates go up in the U.S. And diabetes can have detrimental effects throughout your body. Type 1 diabetes is usually referred to as early onset. It doesn't have to be early on. It can start later in life. But basically, this one is your body is attacking its own pancreatic cells, destroying them. They're not able to produce insulin, and then you have to start taking insulin shots. I mean, a long time ago, it would have been difficult to make it with this disease very long. Now it's pretty easy because you see people that have those little ports and they're on their side usually. They have a little port that goes into their belly, and then there's like a little computer monitor that's constantly testing their blood sugar, and it puts in insulin as needed. 20, 30 years ago, before those, you would have had to keep up with the chart of all the food that you're eating, had to figure out how much sugar you're taking in, and then calculated how much insulin you need, and you would have to like shoot up with insulin. I don't know how many times a day, like maybe every time you ate a big meal, in order not to have a explosion of blood sugar go up. So that's another autoimmune. Multiple sclerosis, Mariah?
WBCs attack the Schwann cells and myelin sheaths of neurons, leads to muscle burn.
Yeah, so the breakdown of the myelin sheath, your body's attacking it. You can imagine the difficulty that would be in terms of able to transmit nerve transmission. It makes those muscles burn and it's painful. So another autoimmune disorder. Now, the rest of these are immunodeficiency, meaning your immune system is deficient. It's not functioning like it's supposed to. It says having no. You might put lack of or no. No is kind of a big. I don't think that's accurate. Maybe no specific immune system. That might fall in one of these categories. The first one's SCID, not to be confused with SID, which is sudden infant death syndrome. SCID, I can't remember what it's short for. I don't know. Severe combined immunodeficiency. Functional lymphocytes are rare or absent. So these are your bubble people. They have no specific immune system or very little. And basically, a lot of these kids have to live in like a bubble. They're isolated from other people or they would die. It'd be similar to someone who would have HIV, where if you get HIV, human immunodeficiency virus, which is number 4, it's going to affect your helper T cells. Your helper T cells are the main control center for what?
Response.
Your specific immune response. And so the same kind of thing with SCID here is you don't have that specific immune response. You're not able to fight stuff off once they get in you and start infecting cells, which is a big issue. There was a movie. It's Monday, sorry. There was a movie called Bubble Boy, I think back in the 90s that came out. You remember that?
Yeah.
It's kind of a funny movie, but and then there's been 2 or 3 like romantic love teenage movies the past 5 years or so where like I think a girl had something or her parents told her she had something like this. Y'all know what I'm talking about? And then her and her boyfriend got together and then she's like, I just want for love. I'm going to kiss you. I don't care if I die or not. And then it turns out she wasn't really sick at all. Isn't that the case?
Yeah. Are you talking about Rocky Park?
I don't know. I'm just somebody told me about it.
Sounds like it.
I don't think it was
That
that
one's
one.
cystic fibrosis.
They were both sick.
Whatever.
No, it
They
was
were
a different.
both sick.
I know what one you're talking about. I vaguely remember like seeing commercials or something for that.
Yeah. I don't know where the movie went, but I did see the commercials. That's kind of the premise behind it. Anyway, and then there was a famous Seinfeld episode for this. There was a Bubble Boy. Are y'all familiar with Seinfeld?
Yeah.
The sitcom back in the 90s, like one of the most famous sitcoms ever. And George goes and visits the Bubble Boy, and I think actually bursts his bubble. Anyway, and so you could imagine the difficulty without having that specific immune response. It'd be like HIV/AIDS. I mean, it wouldn't take you long to get some type of secondary infection. Anything that normally our bodies would fight off, we might get a little bit sick, but normally our bodies would fight off, and you would die from it. All right, stress has been known to weaken the immune system. As you get older, your body's immune response gets slower and slower and less able to fight off stuff. Even though you would think the older you are, the better you would be off against diseases. Why?
Because you've been exposed to more.
You've been exposed to a bunch of them, so you shouldn't. I mean, like, unless it's just something super new like COVID or something, like, you should be able to fight it off. But typically, even like the flu, I mean, like, that's winds up getting a lot of older folks. And so it's just that slower kind of like your body's not reproducing cells as fast. It's not able to handle that kind of infection as you get older. And then another one, number 2 there, Miranda.
Hodgkin's lymphoma. This is a cancer of the lymphocyte white blood cells. Lymph nodes destroyed.
Yeah, you destroy those lymphocytic white blood cells with that cancer and you got issues. There's a non-Hodgkin's lymphoma that's been linked to use of Roundup. I don't know if y'all heard of that one. I know we talked a little bit about Roundup in apes last year. I don't really know the difference between each one of those, to be honest with you. But anyway, anytime you see a lymphoma, you're gonna have some negative impact on that those lymphatic system and your body's ability to fight off disease. All right, now. Animals aren't only the only ones able to fight off diseases and disorders. Plants, they have to be able to deal with viruses, bacteria, fungi, just like we do. All right, and so how do they go about doing this? First of all, virulent means deadly. Non-virulent just means usually harmful to the plant. So let's go through some examples. Part A, Sarah.
Gene for gene recognition. This is a result of coevolution. Resistance genes like bacteria have. If receptor protein matches the infecting ligand, no infection occurs.
Yeah, so it's a way of, like bacteria have, of recognizing a specific gene of something harmful. And so some plants are able to do that in some respect. Elicitors, you don't really need to know a whole lot about these. Ashlyn?
These are plant cell walkies traveling down the
Phloem.
phloem, indicating damage has occurred above. Oligosaccharides released to cells, causing them to produce phytoxylins and PR proteins, antibiotics.
All right, so basically, like I said, don't get too caught up in all the details here. These elicitors are essentially like an antibiotic that's produced by the plant when there's an infection. The phloem is what carries the food and the sugars that are produced by the plant. And so a way of just fighting off infection with basically some antibiotic-like proteins. And then hypersensitive response, Mason?
Massive release of phytoalexins and PR proteins to injured infected cells. Causes a sealing off effect in leaves. This tries to keep pathogen from advancing further. This creates a dead zone that the pathogen may not be able to move past.
All right, so if you guys have any roses at your house, a lot of times they'll get these little black spots on them and then they turn yellow and the leaves fall off. Well, what's happened most of the time is like there's a fungus or bacteria that started growing on there. The plant's like, hey, we're infected over here. We're going to seal you off, like, you know, that Alien movie where they sealed it off and tried to send it out in space. Anyway, they seal off that plant leaf, and then so it keeps that virus or bacteria or fungi or whatever from going to the rest of the plant. That's its way of getting rid of it. And then the last one, systemic or the whole plant acquired resistance, accomplished by using salicylic acid production. We know salicylic acid as the natives used to chew the willow bark for salicylic acid. We call it, this is how I know none of y'all read your notes, because in the next sentence we call salicylic acid aspirin. That's how I know none of you read your notes. Okay. Plants, no, I know we're all egotistical narcissists that only think about ourselves as any good human is. Plants aren't producing aspirin for us, are they? That's what we think, right? Plants produce it for us, sure? No. Plants are producing it for them for their own response. We've just figured out how to take that and use that. Thank you, plants. We should be a lot more thankful to plants. Stop chopping them all down. All right. So you've got an FRQ we're going to do. So clear off your desk and get up. Well, actually, you can keep out your notes.